All right, it's working. Okay. All right, so the last, for right now, operational functions that we'll look at is the composition of functions. So I have two functions, f of x equals x squared plus x plus 2, and g of x equals negative 2x plus 1. So before we dive in, let's look at a little bit of notation. So we looked at multiplication, which was a dot between my two functions. Composition of functions will have a circle. So f of g of x means I am literally going to take g and plug it into the x of f. So I'm going to take f, and I'm plugging g in x's spot. Okay? So the way this is read, in this order, I have f first. So this is f of g of x. F of g of x is how you would say that. And when it is in this order, because with composition of functions, the order does matter. You will get a different answer depending on the order you do this. So f of g of x, we are going to plug g into f. Plug g into f. Okay? And again, the order does matter, so I can do it the opposite direction. G of f of x. The order is reversed, so this means g of f of x. And again, if you notice, g of x is what I plug into my function, and we've replaced that with f. Right? So this is g of f of x. In this order, we're doing the reverse. We would plug f, or substitute f, into g. Again, just like with all the other operations we've looked at, this x that's chilling out here on the side, we do not multiply by this. This is simply telling you what you plug in. Okay? Do not multiply. All right, so let's look at these two operations. So let's first do f of g of x. So I want to find or compute f of g of x. Again, in this order with this notation, f of g of x means I'm going to take f and plug g inside of it. So I'm going to take f and I'm plugging in g. So I'm going to plug in negative 2x plus 1. So that means looking at f, everywhere there is an x value, instead of x, I will have g, all of g. So, looking at f, I have x squared, so I'm going to have negative 2x plus 1 squared plus just plain old x, so I'll have plus negative 2x plus 1 plus 2. So same function, I just have g plugged into x's spot. And so now going through and simplifying, negative 2x plus 1 squared means negative 2x plus 1 times negative 2x plus 1. And I'm going to come over here and do a little side note and multiply that out. Negative 2x plus 1 squared means negative 2x plus 1 times negative 2x plus 1. And we just looked at how to multiply functions. I'm going to distribute everything in the first set of parentheses to everything in the second set of parentheses. So that'll give me 4x squared minus 2x. Now multiply the 1, negative 2x plus 1. So I get 4x squared minus 4x plus 1. So negative 2x plus 1 squared gives me 4x squared minus 4x plus 1 plus negative 2x plus 1. So positive negative 2x is still negative 2x. Positive 1 times 1 gives me positive 1. and then my plus 2. So I distributed or multiplied negative 2x plus 1 squared, and this is a positive 1 just like we have the negative 1, but it doesn't change signs. So I have negative 2x plus 1 plus 2. And again, combining my like terms, I just have 4x squared, no other like terms, so it comes down. With my x's, I have negative 4x and negative 2x, which gives me negative 6x. And then with my plain constants, I have a positive 1, a positive 1, and a positive 2, giving me positive 4. So that's f of g of x. And so let's do the reverse or the opposite and compute g of f of x. So now this is the reverse. Instead of plugging g into f, I'll be plugging f into g. So in x's spot with g, I'm going to plug in all of f. So all of x squared plus x plus 2 will go into g. X squared plus x plus 2. So remember, g of x is negative 2x plus 1. So just in x's spot, instead of x, I'm going to have all of f. So I will have negative 2 times, instead of x, I'll have x squared plus x plus 2. And then finish off my function, plus 1. And now just simplify. So I'm going to distribute the negative 2. Gives me negative 2x squared minus 2x minus 4 plus 1. My only like term is my constant. So I have negative 2x squared minus 2x minus 3. And again, just like with addition and subtraction and what we looked at with multiplication, if there is a value in here for x, you can again just simply compute everything and then plug in your value at the end.